Once you have received the folder of ortosky week zip, the first thing you have to do is extract it on the C unit of your computer. This may take some seconds. And once this is unzipped, you have to go inside the ortosky week folder and the ortoDrone folder to look for the ortoDrone.exe to install it by clicking it 2 times. Now we enter in the product registration window, where you have to click on the second option, configure as a trial, and then press OK in the next window. Now you will have to fill some required fields: the company or entity that you are from, your contact name, your house name and or number, your country, your telephone number, and the most important, your email address, where we will send you an email with a verification link. On this window, we will say you that the mail has been sent. And for following this process, you can also check the installation PDF included in the ortoDrone folder. If you open your email and press on the validation link, now you have access to ortoDrone. And by pressing again in ortoDrone.exe, you will access to the program. We have to say OK in that window, and now the program will open. Here we have to click on the Create New Project button to create a new project. And to check all the data that we need, we have to go to the folder included in the ortosky week zip called trial data. Inside trial data, we will see all the data that we need to build this first project. In images, we can, in the image folder provided by our partner BirdView from India, we can see all the images that we're going to use in our first project, as you can see here. Then in coordinate system, we have the data of the coordinate system needed. Then we have the camera parameters in an Excel file with the sensor width and height in millimeters and the focal length. Then in photo centers, we have the coordinates of our photo centers with 3 different data: the picture name with its extension, and the coordinates X, Y, Z, and omega, phi, and kappa. Then we have an MDB for the captured geometries. Now, by using this information, we are going to be able to create the new project. The first thing that we have to do is to check the orientation of the images by looking the sensor width and height. In this case, the wider side of our pictures is the horizontal one, so that will correspond with the sensor width. We can see the orientation of our flight by selecting one image and put it in above another one, checking also the overlap of the flight. So now we have to copy all this data and go to the project and press Add New Camera. Here we can enter the name of our camera if we have the concrete model, but here we will say camera trial. And by pressing OK, a new camera will be created. Here we have all the data of our camera, and we have to change the sensor width with the data that we copied of our document, the sensor height that we also copy and paste in our new camera in ortoSky, and the focal length that in this case is 16. Now that we've set all these parameters, we can save this camera into an XML file in order to use it in other projects and do not have to create another camera every time that we're going to create a project if we always use the same camera. So we will save it here in trial data. Then we will be able to load this camera. Now that we have the camera created, we can go to add the images. First of all, we have to change the coordinate system. In this case, we go to a TXT with this data, and in the first part of add image window, we can select the projected system of coordinates, and then we select the folder that contains all the images that we want to use in our project. By clicking OK, all the images will be loaded in our project. And here we can see them, and if we click one of them, we can see all the data related to the EXIF data of the pictures provided by the camera. Now, if we open the workflow, the project must this workflow will be synchronized with the data that we've set in these configuration steps, and the workflow will open. Now we will see the phase 1 in the internal orientation, and we will leave all the parameters as they are. By clicking on the phase 1, all the process will start, and here we can see that the process is running with the green light, and we can also check the activity of the process. This process may take around 4 minutes, and when these two lights are red, this process will have finished. Also, in the window, in the right window, the command will say that the process is finished. The time that this process may last depends on your computer. Now the process is finished. And we can close the workflow. Here, if we go to the image pair tab, we can see the image pairs, And by double clicking on them, we can see the type points generated with the program. And if we click in the images, we can see the images in the image tab. Now we open the workflow again and we go to the phase 2. In the phase 2, we need to load the photocenters file. And we have to check on the orientation file only. And here we can select the file that has the information of our photocenters inside trial data folder. Here, if we want, we can change the information columns. And we have to specify that the coordinates of the angular units that we have used are centesimal degree. Now, all the other options that we are going to choose is that we are going to check the generate undistorted folder options in order to generate the stereoscopic pairs in a new folder. Now we can click on the process, and again this process will start and last 2 minutes. Once the process is finished, by this message here and the red lights there, we can go to we can close the workflow and go to the folder of images where new folders and files are created. These files in the output folder, we can see the undistorted images and the camera file and the aerial triangulation file. Now here in the product window, we can click on the products that we want to make with the data that we've processed. Here we can check on generate low resolution orthophoto, generate high resolution cloud, that is the process that will last more time, and generate high resolution orthophoto. In next videos we will explain how this process works and how to load a file with all this data already configured and processed.